Hi, this is Mohammad Nadeem from Exam Help Web. In this video, I am going to describe what electric circuit is and what are the possible combination of electric circuit. One simple way of knowing electric circuit is to recall what do you do when you enter into home. You press electric switch, instantly it turns on electric light. You press TV button, it turns on your TV. The moment you press this button again, it turns off the TV. It means then that these electrical appliances are connected with some metal wires and eventually are connected with source of electricity. These metal wires provide to and fro path for electric current to flow, and this path of electricity is called electric circuit. When you disassemble any electrical appliance, inside you find tiny electrical devices connected on a circuit board, one of which is resistor that controls the flow of electric current in the circuit. Function of resistor resembles water tap. Flow of water depends on how much you open the tap. The more you open, the more it allows water to flow through it, and the moment you close the tap, it stops the flow of water. For resistors, it is the metal that allows the amount of current flow through it. Few metals allow high amount of current flow through it, while others allow very small amount of current flow through it. For any electric circuit, if two or more resistors are connected end to end, is called resistor in series. For series circuit, the amount of current at all the points in the circuit is the same. This means current for resistor R1 is equals to current for resistor R2 is equal to current for resistor R3 and is also equal to current at point A and B. The voltage in series circuit divides in the individual resistors. The sum of the voltage is divided. It means that voltage for resistor 1 is IR1, voltage for resistor 2 is IR2 and voltage for resistor 3 is IR3. And we know the total voltage is the sum of individual voltages. If I is the current, amount of current, then according to Ohm's law, V is equals to IR, V is equals to IR1 plus IR2 plus IR3. We know V is equals to IR, then IR is equals to I R1 plus R2 plus R3. We can cancel this. So therefore the total resistance in series circuit is the sum of all the individual resistances. So in series circuit, the total resistance is the sum of individual resistances. Let's take if I is 1 milliampere here and this resistor is 2 kilo ohm, R2 is 4 kilo ohm and R3 is 6 kilo ohm. Let's see, IR1 is 1 is to 2 is 2 volt, V2 is 1 is to 4 is, and voltage 3 is 1 is to 6 is 6 volts. So the total voltage in series circuit is sum of the individual voltages. 2 plus 4 plus 6 is equals to 12 volt. The total resistance is 2 plus 4 plus 6 is equals to 12 kilo ohm. We use series circuit when we need a constant current in the circuit. It means series circuit is a voltage divider, but the current is constant at all the points. The most familiar example from our daily life where we use this series circuit is a string of LED light that we use for decoration purposes. Another example is the runway lights, and the runway lights are used to guide pilot at the time of landing of an aeroplane. Resistors are said to be connected in parallel if two or more resistors connected side by side across 2 points A and B. The current in parallel circuit at point A has 3 paths to flow. The total current is split into amount I1 for resistor R1, I2 for resistor R2 and I3 for resistor R3. The current enters at point A must be equal to the currents reaching at point B. Means I is equals to I1 plus I2 plus I3. Resistors in parallel have a common voltage across them. VR1 is equals to VR2 is equals to VR3 is equals to VAB. The current for resistor is V upon R1. The current for resistor R2 is V upon R2 and current for resistor R3 is V upon R3. The total current we know I is equals to I1, I2 plus I3. It means V upon R1, V upon R2 plus V upon R3. And we also know I is equals to V upon R is equals to V upon plus, we have taken V common, we can cancel this. So therefore the equivalent resistance in parallel circuit, the reciprocal of is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In parallel resistor circuit, the equivalent resistance is always less than the smallest resistance in the circuit.